Hi guys, IBM is here to bring you another episode of Learning Physics. Do not forget to like these videos. You can share them, download the documents in the video description and share them with your friends. If you're a teacher, you can share them with your students so that they improve their confidence they improve their confidence in AS Physics. So without wasting time, remember we are dealing with solved past paper questions, and this is AS Physics 9702. This is going to be kinematics and dynamics, and of course this is going to be part 3. So without wasting time, let's go to where we stopped in part 2. So in part 2, I think we stopped on this page, that is page 16. So let's start with part 3, page 17. So a lead sphere is released from rest. That means initial velocity is 0 at point X, a long way above the surface of a planet. The sphere falls in a vacuum. There's no air resistance. After a time of 4 seconds, it has fallen through a vertical distance of 3 meters. Assume the acceleration of free fall is constant. How far will the sphere have fallen from a point X to a point at a time of 20 seconds after release? So let's say this is point X. Let this be point X where initial velocity is 0. Then after 4 seconds, it has fallen a distance of 3 meters after 4 seconds. This is t equals to 4 seconds, distance of 3 meters. Then we want how far will the sphere have fallen from point X at a time of 20 seconds. So of course at the time of 20 seconds we expect this distance to be bigger. So let's call this distance, I'm going to call it distance S or distance D, and the time is 20 seconds. Okay, so I'm just simply going to consider equations of motion since the acceleration is uniform. So using S equals to ut plus a half at squared. For a distance of 3 meters, initial velocity is 0 since it starts from rest. So this will be equal to a half times the acceleration. We don't know the acceleration on that planet, so we do not consider it to be the Earth. So I will just say times the acceleration A, and the time taken is 4 seconds. So this is times 4 seconds. So that will be 4 squared. So this gives us the acceleration. So the acceleration is going to be 6 divided by 4 squared, which is 16. And I think this will be 3 over 8. Let it be 3 over 8. That is divided by 2. 3 over 8 meters per second squared. That is the acceleration. So I will repeat the same using the same equation for an unknown distance d, using s is equal to ut plus a half at squared, and the distance is going to be d. Initial velocity is still 0. I'm starting from x, so that will be a half times the acceleration. Of course, the acceleration is the same, which is 3 over 8. And it is taking time of 20 seconds, so this will be just times 20 squared. So I will just press my calculator. A half is 0.5 times 3 over 8, then times 20 squared. So this is giving me the 75 meters. So our answer is going to be B. A box rests on the earth as shown. Newton's third law describes how forces of the same type act in pairs. One of these forces of a pair is the weight of the box, which arrow represents the other force of the pair. Of course, for Newton's third law, the two forces must be acting in the same point. The two forces must be acting in the same point. They must be acting in the same line. Their lines of action is the same. For them to be able to cancel out each other, their lines of action should be the same because they should be equal but opposite, and their resultant should be 0. They should be acting in the same line. So if If they said one of the forces of a pair is the weight. Newton's third law describes how forces of the same type act in pairs. One of the forces of a pair is the weight. It's the weight W of the box. Which arrow represents the other force of this pair? So we are just looking for a force which is acting in the same line as the weight. Of course, it can't be D because the weight is downwards. It can't be B because B is upwards, but it can't be C because C is also downwards. Why can't it be B? It can't be B because we can even check the magnitude by looking at the length of these arrows. So for the weight, it is about 1.3 centimeters. A is about 1.3 centimeters. And B is slightly bigger. Okay, so the answer is automatically going to be A. The answer is going to be A. First of all, it should be in the opposite direction to the weight. They should be equal in magnitude and they should be acting through the same point. Of course, the weight must be acting through the center. So the weight must be acting through the center, but you notice that where W is placed is not the center, so it is supposed to be around here, but since they wanted to distinguish it from B, so the answer is going to be A. Alternatively, you can also think about it. Of course, this is also acting from the center. If the weight of the body acts from the center towards the earth, then also the force of the earth onto the object must be acting from the center towards the object. So the answer is still A. Okay. A snowflake is falling from the sky on a still day. Its weight acts vertically downwards and air resistance C acts vertically upwards. As the snowflake falls, air resistance increases until it is equal to the weight. There is no resultant force acting on the snowflake. When the forces become equal, which statement is correct? Of course, when the forces become equal, the resultant force is 0, the acceleration is 0, the velocity becomes constant. That is what we call terminal velocity. So that means the answer is going to be D. The snowflake moves at a constant velocity when there is no resultant force. Two boxes X and Y in an isolated system undergo perfectly elastic collision. The velocities of the boxes before and after the collision are shown. What is the speed v of y after the collision? Speed v of y after the collision. Okay, so since it is a perfectly elastic collision, then we shall simply say that the relative speed of approach should be the same as the relative speed of separation. So relative speed of approach, since they're in the same direction, relative speed of approach is simply 20 minus 12, which is 8 meters per second. Then the relative speed of separation since they are also in the same direction, should be v. Relative speed of separation should be, of course, since y is forward, is in front, so it means v is greater than 10. So this should be v minus 10. So these two should be equal. So I'll simply say that 8 should be equal to v minus 10, which means that v is equal to 8 plus 10, which is 18. The relative speed of separation should be the same as the relative speed of approach, so the answer is going to be 18. An archer shoots an arrow at a target. The diagram shows the path of the arrow. Okay, so let's first draw a horizontal line here. So it is a projectile. Air resistance is negligible, so it means the acceleration in the vertical is the force due to gravity is the only force acting. The graphs show how three different quantities P, Q, R, and R vary with time. Which quantity could be horizontal component of displacement and which quantity could be the vertical component of displacement of the arrow? So I want you to notice that the vertical displacement increases, the horizontal displacement increases to a positive value. So it will just, because this is Sx, it increases to a positive value. So Sx increases to a positive value. But then this is the horizontal displacement. The vertical displacement will increase to a positive value and then it goes to a negative value. So S in the vertical increases, then decreases to 0. So this is S in the vertical increases to a positive value, and S in the vertical increases to a negative value. So the resultant will be 0. So Sy will first increase to a positive value, then it will decrease to 0. So total displacement will be 0 in the vertical. So which quantity could be horizontal component of displacement? For it just increases. So it means Q must be horizontal component of displacement because for it increases to a positive value. So this is S in the X. Then vertical displacement, it increases to a positive value, then it decreases back to 0. So this is going to be S in the Y. So the answer is automatically going to be B. Horizontal component of displacement will be Q because for it just increases up to the highest, up to the positive value, up to where it hits. And then the vertical component goes up, it increases to a positive value. Then if the object comes back to the same level, it goes back to 0. So this is R. R is the vertical component. So the answer is B. Two cars X and Y are positioned as shown at time t equals to 0. They are traveling in the same direction. X is 50 meters behind Y and has a constant velocity of 30 meters per second. Y has a constant velocity of 20 meters per second. What is the value of t when X is level with Y? Okay. So let that time be just t. Let's consider Y first. The displacement for Y, we are going to assume that, of course, if the speed is constant, then distance is just speed times time. So the speed, the displacement or the distance for Y is going to be 20 times that time. And because what is the value of time when they level? When they level, they must have traveled, of course, for the same time. Then S in X is going to be equal to remember X is behind Y by a distance of 50 meters. So the distance for X is going to be 50 plus the distance it will have covered, which I'm going to call S. But of course, if S travels a distance, if Y travels a distance 20 times t, then it will have covered a distance S, and also X will have covered the distance. They cover the same distance if they're traveling at a constant speed. By the time they level, they must have covered the same distance. They will have traveled the same distance in that time, which I've called t. So this one will be 50 plus S. Oh, sorry. X will have traveled a distance which is 50 plus S. If S has traveled a distance, just S. If Y has traveled a distance S, then by the time they level, X must have traveled a distance 50 plus S, which Y has already covered. Okay, that is very true. Then when I look at these equations, so this is going to be, a distance is speed times time. The speed is 30 and the time is t, they will of course have traveled for the same time t. So I have that 20 times t equals to s, and I also have that 30 times t equals 50 plus s. 50 plus s. So we have those two equations. They are two unknowns, so I'll just put one into the other. So I have that 30 t equals 50 plus s, which is going to be 20 times t. So I have that 10t is equal to 50, which means that t is equal to 5 seconds. So the question is, what is the value of t when x is level with y? So the answer is automatically going to be d, 5 seconds. Okay, so I said when y travels a distance s, which is 20 times t, x must travel distance 50 plus the distance covered by y by the time they level. But of course, they will have traveled for the same time t by the time they level. So I equated those two equations and found t as 5 seconds. A constant resultant force acts on an object in the direction of the object's velocity. Which graph? It is a constant resultant force. Which graph could represent the variation with the time t of the momentum p of the object? Remember that the constant resultant force acts on an object in the direction of the object's velocity. So it means if it is in the direction of the object's velocity, then the momentum must be positive since f is in the same direction with the velocity. So this must be positive because f is in the same direction with the velocity. So the acceleration must be positive because the force is in the same direction with the velocity. So the acceleration must be positive. We know that force is equal to mass times acceleration. And since f is constant, a is constant because they are directly proportional. A must be constant. And we also know that force is equal to the rate of change of momentum. And the force is constant, so the gradient is constant. So the gradient must be constant. Because f is constant, the gradient must be constant. What does that mean? It should be a straight line. So constant gradient means a straight line. So we ignore A, we ignore B because those are not straight lines. But then the resultant force is in the same direction as the object's velocity. So it means the gradient must be positive. So this part here is telling us F, same direction as velocity. If the resultant force is the same direction as the velocity, the acceleration is positive, so the gradient must be positive. Okay, so that means our answer is going to be C. C is the one giving us a positive gradient. Which statement must be true for an object in a gravitational field? Okay, if the object has mass, then the field causes it to accelerate. Okay, if the object has mass, then the field causes it to have weight. I think this is very true. If the object has mass, then the gravitational field causes it to have a weight because the gravitational field is going to be the force per unit mass. So it will be the weight divided by the mass. If any object has mass, then the field will cause it to have a weight. If the object has a mass, then the field causes it to accelerate. There could be other factors such as air resistance so that the acceleration of the object is zero. But then, as long as it has a mass, it will always have a weight. So the answer is automatically B. A ball of mass 0.16 kilograms traveling horizontally at a speed of 20 meters per second. It collides with the wall and rebounds. Because to rebounds, one is going to be positive, the other one is going to be negative. Along its original path, the ball is in contact with the wall for a time of 1.0 milliseconds. What is the average force exerted by the wall on the ball? So force is the rate of change of momentum. So this is going to be mass times change in velocity divided by time. So this is going to be mass, which is 0.16. Change in velocity, one positive, let's say 20 positive, minus the other one is negative, divided by the time of contact, which is 1.0. So I have 0.16 times 35. So the answer is 5.6. Oh, this is 1 millisecond. I had not seen this. This is 1 millisecond, so that is 1 times 10 power minus 3. To change it to seconds. So divide by, open brackets, 1 exponent minus 3. So that is 5,600. 5,600 newtons. So it means the answer is going to be D. The graph shows the variation with time of the acceleration of a car. What must be the shaded area under the graph? Okay. We see the acceleration is constant, so the equations of motion can apply, such as V is equal to U plus AT. V is equal to U plus AT. So it is a graph of A against T. So I'm going to make A the subject. So AT is equal to V minus U. So it means acceleration is equal to V minus U times 1 over T. Or V, sorry, I don't need the second part. I'll erase this one. So A times T is equal to V minus U. So the question, what, and A times T, I think that is area. So area is equal to V minus U, which is change in velocity. So what must the shaded area and the graph represent? So it is showing change in velocity of the car. A stone is thrown horizontally off a cliff and then lands in the sea. Air resistance is negligible. Which statement about the stone's motion is not correct? Not correct. The final displacement of the stone depends upon its initial horizontal velocity. The stone is thrown horizontally. The final displacement of the stone depends upon its initial horizontal velocity. Final displacement, let's check. S equals to ut plus a half at squared. Of course, if I consider vertical motion, initial velocity is 0, so the displacement is not necessarily depending on its initial velocity. And then the stone travels with a constant horizontal component of velocity until it hits the water. The stone travels with, no, they said which statement about the stone's motion is not correct. So this can be correct. The stone travels with a constant velocity in the horizontal, that is correct. Velocity in the horizontal remains constant. The stone travels with an increasing vertical component of velocity, that is very true. Velocity in the y is going to be u plus acceleration in the y times t, because there is an acceleration in the y. As time increases, velocity in the y increases. So that is true. The time taken for the stone to hit the surface of the water depends on its initial horizontal velocity. I think this is not true. The time does not depend on its initial velocity, because I can still find time from any expression which has no initial velocity. Even using vertical motion, I can find time. So the time does not, because time is a scalar quantity, it will not depend on the initial horizontal velocity. Simply because air resistance is negligible, the time will depend on the acceleration. So the answer is D. Water is pumped through a hose pipe at a rate of 90 kilograms per minute. Water emerges horizontally from the hose pipe with a speed of 20 meters per second. What is the minimum force required from a person holding the hose pipe to prevent it moving backwards? Okay, so force is the rate of change of momentum, which is mass into v minus u, change in velocity over t. They have given us m over t as 90 kilograms per minute. I'll just change it to per second. So it will be 90 per second, which is over 60, because 1 minute is 60 seconds. Then into brackets, the water emerges horizontally. What is the minimum force required from a person holding the hosepipe to prevent it moving backwards? So it means the final velocity should be 0. So this will be 20 minus 0. And I think that is 90 divided by 60, zeros cancel out, and this gives us 30. So the answer is going to be A. You can check with the calculator, but I think it is 30. 90 times 20 divided by 60. So that is 30 newtons. A skydiver leaves a stationary balloon. It is a stationary balloon and falls vertically through a long distance. Which graph best represents the variation of the acceleration A of the skydiver with distance s traveled as she falls through air? So she's falling through air. That means they must reach a point where the acceleration will become 0 if she's falling through air. So all these are graphs of acceleration against displacement. So the acceleration must go to 0 because she's falling through air. As she falls through air, the v speed increases, which means force due to air resistance increases. And if the force due to air resistance increases, it means the resultant force Fr decreases, which means the acceleration also decreases because the resultant force is mass times acceleration. So it decreases until when A becomes 0, it means the speed, of course, we shall have reached terminal velocity and the velocity becomes constant. So since these are graphs of acceleration against displacement, the acceleration, as the displacement increases, the acceleration tends to 0, of course. The point is going to reach where the acceleration becomes 0 as the displacement continues increasing. So this one is showing acceleration increases and becomes constant, which is wrong. This is showing constant acceleration when there is air resistance. This one shows that acceleration is directly proportional to displacement, meaning the acceleration continues increasing, which is not true. So the answer is going to be A. The acceleration decreases because the resultant force becomes smaller, simply because air resistance increases. And remember, the resultant force is always the weight minus the force due to air resistance. When the force due to air resistance becomes bigger, the difference becomes smaller. And the difference is the resultant force. When the difference becomes small, it means the acceleration decreases because the resultant force is mass times acceleration. As this decreases, A should also decrease. So that means the answer is A. The diagram shows two spheres approaching each other head-on. Each sphere has a mass speed u. One sphere has mass 2m and the other has mass m. The diagram shows the resultant of a perfectly elastic collision. A perfectly elastic collision. Remember, for perfectly elastic collision, relative speed of approach is the same as relative speed of separation. They should be equal. So let's first find the relative speed of approach here. So these are moving in opposite directions. So relative speed of approach is going to be u minus negative u, which gives us 2u. So it means also the relative speed of separation should be the same, should still be 2u. Let's check A. A is, these ones are in opposite directions, so we shall say 5u over 3 minus negative u over 3. So the LCM here is 3. So we have 5u minus u, sorry, plus u, because this is minus negative, so it becomes plus u. which gives us 6u over 3, which is equal to 2u. So it automatically means the answer is A. I don't expect another one to give us the same answer, so the answer is going to be A. I subtracted minus, but because to the left is negative, to the right is positive, so it is minus negative, which becomes plus. So it gives us 6u over 3, which is 2u, which is the same as the relative speed of approach. So that means the answer is A. So here I was checking relative speeds of separation after collision. So the answer is A. A spherical object falls through water at a constant speed. Three forces act on the object. Which diagram showing these three forces to scale is correct? So all of them have a vertical force acting downwards. One of these forces should not change in magnitude, and that is going to be the upthrust. If it is falling through water at a constant speed, the resultant force must be zero. Resultant must be zero. So resultant force must be zero. So when you combine the two, you should get the force in opposite direction. So D and C are automatically out, because when you measure the length of these arrows, and combine them, you may not get this. Let me check. I'm measuring the length. So the downward arrow is about 2.5 centimeters, but these small arrows upwards, this is 0. They are 0. About 0.9, approximately 1 centimeter. So when you combine them, these will give you about 2 centimeters. So this one is also automatically wrong. 1 centimeter and less than 1 will not give us 2.5. So when I check here, A is automatically wrong, because this is approximately 2.5 centimeters. This is 2.5 centimeters. But when I add this 1 centimeter, so it means upwards to be greater than downwards. So the answer is going to be B, because let me check. This is 1.5 and the short one is 1 centimeter. So this is 2.5 centimeters. This is 1.5 and this is 1. When you add up, you get 2.5. So the answer is B. Resultant force is 0. I've just checked the magnitudes by measuring the lengths. You can also do that. The graph shows the variation with time t of the velocity of a vehicle moving in a straight line. The vehicle moving at 4 meters per second begins to accelerate at t equals to 0. What is the vehicle's acceleration at t equals to 3.0 seconds? So at 3.0 seconds, because acceleration is the gradient, I'm just going to draw a tangent at 3.0 seconds. So I'm going to draw a tangent at 3.0. Of course, when you're drawing, the tangent should be perfectly balanced. The line should be symmetrical, completely symmetrical. Okay, so I've tried to draw a tangent. You can try to draw a better tangent than me. So if I draw this tangent and I try to find the gradient of this triangle, so the acceleration is going to be the change in v over the change in the difference in time. So the change in v is going to be I think that is 10 minus 2 divided by 6 minus 0, and this is giving me 8 divided by 6. What is 8 divided by 6? I think that is 1.3 recurring, so that is 1.3 recurring, which makes my answer to be C. Draw tangent at 3, so we find the gradient of that tangent, so that is approximately 1.3. A stone is projected vertically upwards from the ground at an initial speed of 15 meters per second. Air resistance is negligible. What is the maximum height reached by the stone? Remember, at maximum height, velocity is 0. V at maximum height is 0, so air resistance is negligible. I'll use Shuvart equations. I'll use Shuvart. equations. So v squared equals to u squared plus 2as. At maximum height v is 0, so 0 squared is equal to initial velocity, which is 15 squared. Because towards moving against gravity, the acceleration is going to be negative of g. So this will be minus 2 times 9.81 times the distance, which I'm calling h. I'll just press my calculator to find h. So 15 squared on one side divide by 2 times 9.81. So that gives us 11.5 or 11.46 or approximately 11 meters. So the answer is going to be B. What is meant by the mass of an object? Of course, this quantum of matter is a measure of a body's inertia. So let's check. The property of the object that resists a change in motion, that is inertia. So the answer is A. Of course, the pull of the earth, that is weight, total number of atoms, the weight of the object, that is not mass. So the answer is A. The property of the object that resists a change in motion, that is mass. The diagram shows two parachutists, X and Y, moving vertically downwards. The total mass of the parachutist Y, total mass of parachutist Y and his parachute is twice total mass of parachutist X and his parachute. At this moment, the air resistance on parachute Y is twice the air resistance on parachute X. Neither parachutist has reached his terminal velocity. Which statement describes acceleration of Y compared with acceleration of X? Okay. I want you to recall that the resultant force F is equal to mass times acceleration. So let's say the air resistance force on this one is F1, but they said the air resistance on parachute Y is twice that twice the air resistance on parachute X. So if X is F1, this is going to be twice F1. The air resistance is twice F1. But I want you to remember how we get the resultant force. So let's check for X. For X, the resultant force will be the mass times the acceleration of X, which is A, I'm going to call it X, should be equal to the mass M times acceleration due to gravity, then minus F1. I'm just saying that resultant force is equal to the weight minus the force due to air resistance. So resultant force is MA, the weight is mg minus F1. So this side I have that acceleration for X is going to be mg minus F1 divided by m. But they say the total mass of parachutist Y and his parachutist is twice the total mass of X. So if for X is m, for Y is going to be twice m. So let's check for Y. So his mass is twice m times the acceleration, I'm going to call it AY, should be equal to the weight. The mass is twice m times g, then minus the friction for air resistance, which is twice F1. So I just simplify this, the 2 cancels out, so I still have that acceleration in Y is equal to mg minus F1 divided by m. I want you to notice that acceleration in X is perfectly identical to acceleration in Y, so the accelerations are equal. The acceleration of Y is the same as the acceleration of X, so the answer is going to be B. The table shows 4 different collisions between 2 blocks, each of mass 0.5 kilograms. Which collision is perfectly elastic? Remember, for perfectly elastic collision, relative speed of approach should be the same as relative speed of separation. So we are going to find the relative speeds of approach, and we'll find also the relative speeds of separation, and we see whether they're the same. When the bodies do not separate, the relative speed of separation is 0. So here it is 4 minus 0, which is 4. So this means A is out. Here it is 2 minus negative 2, which becomes 4. 2 minus negative 2, because to the right positive, the left negative. So it is 2 minus negative 2, which is 4. So this is out. Relative speed of approach is not the same as relative speed of separation. Let's check C. C is 2 minus negative 1, which is 3. And on this side, we have 3 to the right minus negative 2, which is 5. So this is not correct. So the answer is going to be D. We can check. 4 is to the right, 1 is to the right. So the difference is 3. 4 minus 1, which is 3. Then 4 is to the right and 1 is to the right. 4 minus 1, which is still 3. So the answer is the relative speed of approach should be the same as the relative speed of separation. So the answer is D. 4 cars A, B, C, and D move from rest in a straight line. The cars take the same time to accelerate to a velocity of 60 kilometers per hour. Their velocity time graphs are shown. Which car reaches a velocity of 60 kilometers per hour in the shortest time possible? In the shortest time. So the answer is automatically going, of course, in the shortest time possible, we'll look for the acceleration. Remember, the gradient, acceleration is going to be the gradient. The one with the highest gradient means is accelerating faster. So this one, I think the highest is going to be D, because acceleration increases in D. A increases in D. So it gains speed earlier. So it gains more speed in a short time. So the question is, which car reaches a velocity of 60 kilometers in the shortest distance? So the answer is going to be D, because A, the gradient is decreasing, so it means the acceleration decreases. B, the same thing, the acceleration decreases. Now C and D, the acceleration increases, but it increases more rapidly in D than in C. So the answer is going to be D, because the gradient in D increases more rapidly than C. The gradient in D increases more rapidly than C. So you notice that this would be turning to infinity like that, and the other day these graphs would cross. So the answer is going to be D. A cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. Which equation is correct for the maximum height h reached? Maximum height h reached. Let us assume air resistance is negligible. So if air resistance is negligible, then we can use the Suvat equations. V squared equals to U squared plus 2AS. At the maximum height, remember velocity is 0, so 0, I'm using vertical motion. Vertical motion. So at the highest point, velocity is 0, so 0 squared is equal to, I have to resolve this in the vertical. Resolving velocity in the vertical will be V sine of alpha. So this is going to be V sine of alpha, but this is squared. Because it is moving against gravity, acceleration in the vertical will be negative g. So I will say minus 2 times g, then times the height h. So making h the subject, will give us a v sine alpha squared divided by 2g, which makes the answer to be C. A ball strikes a horizontal surface with momentum p at an angle theta to the surface, as shown. The ball rebounds with the same magnitude of momentum at an angle theta to the surface. The ball is in contact with the surface for time t. What is the magnitude of the average resultant force? So I want you to note that resultant force is equal to the rate of change of momentum. It's the rate of change of momentum. So let's say we're going to consider momentum. Of course, the momentum in the vertical is going to be 0. I mean, in the horizontal, Okay, I'm going to resolve this. In the vertical, P in the vertical is going to point, the first P in the vertical is going to point downwards and to be P sine of theta. So P sine of theta in the vertical. I'm resolving P vertically. Then it points downwards. Then when it rebounds, so it will be minus. When it rebounds, the other will be negative. So I'm finding change in momentum. So the other will be negative. So it is minus negative P again, sine of theta. So it means in the vertical, this is going to be twice P sine of theta in the vertical. So of course, the average force acting on the ball must be in the vertical, not in the horizontal. That's why this is wrong. So the answer is going to be 2p sine theta divided by t. It can't be 2p cos theta because 2p cos theta would mean resolving the horizontal, which will be p cos theta. And this one, the horizontal will also be p cos theta. They will sum up, but this is not going to be the force acting on the ball because the force acting on the ball must be in the vertical. So the answer is going to be D. Okay, so the component in the horizontal will not cause rebounding. It's the component in the vertical which is going to cause rebounding. So the total momentum in the vertical is 2p sine theta. That will be the force acting on the ball during the what is the magnitude of the average resultant force acting on the ball during the collision? So I think that is going to be 2p sine theta divided by t. Okay. A skydiver who is falling vertically through the air opens his parachute. Which row describes the velocity of the skydiver immediately after he opens his parachute? Immediately after he opens his parachute, which row describes the velocity? So, immediately as he opens his parachute, note that force due to air resistance increases. Force due to air resistance increases, and this increases with the velocity. It increases with the v. So it means v is going to increase with the time. So v increases with the time. Just immediately the skydiver opens his parachute. First of all, v is going to increase with the time, and if that is very true, force due to air resistance increases because v is increasing. But then with the time, when air resistance increases, it means the velocity with the time is going to decrease, but it is still the motion is still downwards. So it means direction of the velocity is downwards because immediately we open the parachute, there is an acceleration downwards, so the velocity is downwards, not upwards. And then, but this velocity, because air resistance increases with the time, the magnitude of the velocity is going to decrease because the air resistance is increasing in the opposite direction. So the answer is going to be A. The direction of the velocity is downwards, but then its magnitude decreases because of air resistance. Not until a point when the air resistance is balancing the weight, so the velocity remains constant. If the air resistance exceeds the weight, then the velocity decreases. So the answer is going to be A. A horizontal firework explodes into 4 fragments, which travel in different directions in a horizontal plane. The diagram shows the velocity and mass of each fragment. Okay. It is stationary, so initial momentum is 0. Remember, momentum is mass times velocity. So if it is initially stationary, its momentum is initially 0. So by conservation of momentum, initial momentum is 0. I will not change the masses because I know the units will cancel out. But then they are moving in different directions. So I'm going to consider conservation of momentum. Let me conserve momentum in the horizontal. I think I should conserve momentum in the horizontal. So I'm going to draw a horizontal line here. I'm drawing a horizontal line and I'm conserving momentum in the horizontal. So in the horizontal, let me consider those acting to the left, positive, to the right, negative. The order doesn't matter, or the other way around, it doesn't matter. So to the left, we have 25 grams times the velocity is 240 cos of 45, then plus 15, the velocity is v cos 45, that is to the left, minus to the right. To the right, I have 10 times the velocity 300 cos of 45. This angle is 45, 45, 45, 45. So cos of 45 plus 20 times 300, again cos of 45. So this is the difference. So on one side, I'm just going to take one quantity on the other side so that I just press my calculator. So I have 10 cos of 45. No, it is 10 times 300 cos 45 plus 20 times 30, so times 300 cos 45. So that is approximately 6,000. I'll just round off. So on one side I have 6,000. Is it 6,000? Let me check it again. 10 times 300 cos 45 plus open brackets 20 times 300 cos 45. So that is 6,000. So we have 0 equals to plus 6, approximately 6,000. Anyway, I'll just write 6,000. Then we have 25 times 240 cos 45, which is 4. I'll just write 4,000. So this is 4,000 plus 15. Oh yeah, cos 45 is cancelling out. Why am I wasting my time? Cos 45 is cancelling out because it's everywhere. Yes, cos 45 has cancelled out because of the equal signs, and is everywhere, it has cancelled out. So that is makes it very easy. So 0 is equal to 25 times 240, that is 6,000 plus 15 EV minus 3,000 plus 6,000, that is minus 9,000. So I want V, I will just press my calculator. I take 9,000 on one side, so I have 9,000 minus 6,000 divided by 15. So V is 200. V is 200 meters per second because Cos 45 is everywhere, so it cancelled out. So v is 200 meters per second, so the answer is A. Okay. A projectile is launched at an angle to the horizontal at time t equals to 0. It travels over horizontal ground as shown. Air resistance is negligible, so it means the acceleration is the acceleration due to gravity. Which graph best shows the variation of t of the speed of projectile from when it is launched to when it lands? Of course, for the first part here, which graph best shows the variation with the t of the speed? So speed doesn't mind about direction. So the speed increases, the speed will increase. When it is going upwards, the speed will decrease. But of course here the speed, if we are dealing with the speed, we're not minding, of course, if you are dealing with the speed here, the speed here, of course, in the vertical, it goes to 0. At the highest point, the v goes to 0. But v in the x does not go to 0. So if I'm considering speed, so initially the speed, it is launched with a certain speed, so the speed decreases, but it does not go to 0 because v in the x does not become 0. Then when it is falling, the speed increases until reach the same level as before when it hits the ground. So we should have something like that. So this one is showing the speed remains constant completely. That is not true, it decreases. That's why at maximum point in the vertical it is 0. This one is showing that the speed goes to 0 and then it increases. This one means the speed at the highest point becomes 0. It is not completely 0 because there is velocity in the horizontal. So it doesn't go to 0. So B and D are out because they are saying there is a point where the speed is completely 0, yet there is velocity in the horizontal. So the speed does not go to 0. It is 0 only in the vertical if we consider vertical motion or vertical component, but not horizontal. So the answer is going to be C. The speed decreases. At the highest point, the speed is only velocity in the horizontal, but then when it is falling, it again increases. I think the answer is going to be C. A train initially at rest at a station has uniform acceleration of 0.2 meters per second and it reaches a speed of 20 meters per second, travels for a time at this constant speed and then has uniform deceleration. Uniform deceleration, which makes this one to be negative, and it comes to rest at the next station. The distance between the two stations is 300 meters. What is the time? What is the time taken by the train to travel between the two stations? Okay. So we are going to use conservation of, since let's see, there is uniform acceleration for the first part where there is uniform acceleration, I'm going to use equations of motion. I'll use equations of motion. So for the first stage, I will simply say V1, V, using V, where should I write? Let me write on the side first. So V1 is going to be U1 plus acceleration A1 times T1 initially. So initially, it reaches a velocity of 20 meters per second. So 20, initial velocity is 0 because it starts from rest. Acceleration is 0.2, so is equal to 0.2 meters per second times time t1, which means t1 is going to be 20 divided by 0.2, which is 100 seconds. The first time is 100 seconds. So this is going to be stage 1. So let's see. So that is for stage 1, that is 100 seconds. Let's check stage 2. It travels for a time at this constant speed and then has uniform deceleration. It travels for a time at this constant speed and then has uniform deceleration. So it will travel for that speed and then will have uniform deceleration. Okay, so let me just look at stage 2. Or let me first find the distance which it has covered in stage 1. Okay, so for stage 1, I'll simply say I know that v squared equals to u squared plus 2as. I'm still on stage 1. So v squared is 20 squared equals to started from rest, so that is 0. So this will be 2 times the acceleration, which is 0.2, then times the distance, which I'm going to call S1. So what is S1? S1 is 400 divided by, what is that? 400, or to 20 squared divided by 0.4, which I think is 1000. So S1 is 1000 meters. So it takes 100 seconds to travel 1000 meters. That is in stage 1. Then for stage 2, where should I do stage 2? Okay, stage 2, I should do it here. For stage 2, it travels for a time at this constant speed. So it is traveling at 20 meters per second. So S2, distance traveled, is going to be simple speed times time, since the speed is constant. So this is going to be, speed is 20 times time, which time is not known. So I'll say times T2. So for stage 2, we have that S2 is equal to 20 times T2. That is for stage 2. Then for stage 3, until it comes to rest, then has a uniform deceleration until it comes to rest. So stage 3, I'll use S3. So for stage 3, I'm going to go back and use the same equation because it then has a uniform deceleration of 0.4 seconds. So I'm going to let me use v squared equals u squared plus 2as. So for stage 3, let me use a different color for stage 3. So using v squared, because it comes to rest, final velocity is 0 squared. Initial velocity, of course, is leaving 20, so it is coming from 20 squared. Because the acceleration was negative, so this is minus, because it's a deceleration, minus 2 times 0.4, then times S3 for stage 3. So what is S3? S3 is going to be equal to 20 squared divided by 0.8, which is, I think that is 500. 20 squared divided by 0.8, that is 500 meters. Remember, the total distance is 3000 meters. For stage 1, it has a distance of 1000. Stage 2, it has 20 times T2. Stage 3, it is 500 meters. So it means if I want stage 2, the distance for stage 2 is going to be 3000 minus the sum of all these ones, which is going to be 1000 plus 500, that's 1500. In other words, I'm saying that S1 plus S2 plus S3 should give us 3000 total distance. So when I want to find S2, I get 3000 minus 1500, which is going to be 500 meters. So the distance S2 is 500 meters. Now I go back to the equation S2. S2 is 500. I can find the time T2. So T2, no, 3000 minus 1500 is 1500, okay. So S2 is 20 times T, so I can find T2. So 1500 is equal to 20 times T2. So what is T2? So T2 is going to be 1500 divided by 20. I think that is 75 seconds. This is 75 seconds. That is T2. Remember, T1 was 100 seconds and T2 is 75 seconds. So what is which time is missing, T1, T2, okay, T3 maybe. If I want to find it T3, remember total time, do we have the total time? Okay, let me just find total time. T2 is 75 seconds, T1 is 100 seconds. What is the time taken by the train to travel between the two stations? Okay, so I need to find the time T3. So T3, since it goes to rest, I'll use V equals to U plus AT to find T3. I'm trying to find T3. Or you could also use the distance for 500, but let me use T3. Let me find T3 here. So V is 0 because it comes to rest. It started with a velocity of 20 from a constant velocity minus 0.4 times T3. So I'm finding T3 as 20 divided by 0.4, which I think is 50 seconds. So T3 is 50 seconds when it is returning to rest. So I have T3 as 50, T2 as 75, T1 as 100. So total time is going to be 100 plus 75 plus 50, which I think is 225 seconds. So the answer is going to be approximately C. Yeah, it is quite long, but the answer is approximately C. A rocket is fired from the Earth into space. Newton's third law of motion describes how forces act in pairs. One of the forces of a pair is the weight of the rocket. What is the other force of the pair? The weight of the rocket. Okay, it acts, of course, weight of the rocket will act from the center. Then the other pair must be the gravitational force from the Earth, which acts from the center of the Earth. So the answer is D. The gravitational force of the rocket on the Earth. The gravitation, because the weight is the force of the Earth on the rocket. The weight is the force, the pull of the Earth on the rocket. Then the other force should be the gravitational force of the rocket on the Earth. Okay, so the answer is B. That is Newton's third law. And lastly, for this video, the graph shows how quantity P varies with quantity Q for a body falling vertically downwards in a uniform gravitational field with air resistance. So it means this cannot, for air resistance, this P cannot be velocity against time. So which pair of quantities could be represented by P? So first of all, if it is falling in a field with air resistance, so force due to air resistance must increase with the speed. Because the speed increases, the force due to air resistance must increase with the speed. So if the force due to air resistance increases with the speed, so Q is force due to air resistance, A is acceleration. So remember the resultant force, which is mass times acceleration, is going to be the weight minus the force due to air resistance. Okay, so as the force due to air resistance increases with speed, it means this quantity becomes smaller. So it means the acceleration decreases as the force due to air resistance increases, because the acceleration depends on the difference between those two. So the difference becomes smaller, the acceleration decreases as the air resistance increases. So the acceleration, this graph, if this is A with the time, it means the acceleration decreases to 0 uniformly, so this is wrong. It can't be a straight line. Then velocity against force due to air resistance. As velocity increases, air resistance must increase, yet here it is showing as air resistance increases, velocity decreases. This is wrong. They are not inversely proportional. As velocity increases, air resistance increases. velocity against time. This cannot be velocity against time, because if it is velocity against time, remember air resistance increases with speed, so this graph would somehow become horizontal to show that the velocity becomes constant at some point. So the answer is going to be A. As air resistance increases, the difference between weight and air resistance becomes smaller, which means the resultant force is smaller. And the resultant force is directly proportional to the acceleration. So the air resistance increases, the acceleration decreases, and this is very true. As Q increases, acceleration is decreasing, so the answer is going to be A. Okay, so let this mark the end of part 3. See you in part 4. Bye bye.